Hello everyone. Welcome to lecture 11 or day 11 of the machine learning teach by doing project. In this particular lecture, we will be looking at coding the perceptron algorithm in Python. So in the previous lecture, we took a very detailed look at the perceptron algorithm and saw that it is one of the oldest machine learning models. We saw that this model was invented in 1957 and it was one of the first models which really learned from data. And that's why, although it was not classified as a machine learning model at that time, it really was one. We also saw that this particular model was not just an ML algorithm, but it was also implemented as a machine by engineers of that time. And the first paper which was released on the perceptron, the authors really intended for the perceptron to be a representation of the human brain, although it was extremely simplified version, but still the vision was really moving towards artificial intelligence the way we see it today. I really like the perceptron algorithm because it is one of the oldest ML models, and the roots of all ML models which we see around us right now can be found in the perceptron. We can learn several things from the perceptron, such as training a machine, how a machine learns from data, etc. The primary aim of the perceptron when it was developed was to recognize shapes, patterns, letters, and numbers. Of course, ML algorithms now can do much more complex and powerful things, but it's always good to have foundational knowledge. So, in today's lecture, we will be looking at coding the perceptron algorithm in Python. Essentially, you will write the entire code for the perceptron in Python. Let me tell you why we are learning about this right now. So, as I mentioned, the reference for the perceptron algorithm is this MIT 6.036, which is Introduction to the Machine Learning course. If you go to the perceptron lecture and if you go through their video lectures and if you go through their assignments, you will see that they explain perceptron, which we covered in the previous lecture of perceptron as well. But there is no demonstration of writing the code about this in Python. And I believe that unless you actually write the code in Python, you will not really understand the algorithm itself. You will not really have fun. Even in this Microsoft's lecture, which we have been following, there is no mention, first of all, of the perceptron, even. And there is no coding lesson for the perceptron. So I decided to create a coding lesson all on my own. And I'll also be sharing the code files with you as I do throughout this particular lecture series. So this particular lecture will be about start to end coding of the perceptron algorithm in Python. If you have directly seen this lecture without seeing the previous one, I highly recommend that you go through the previous lecture, because in this lecture I'm not going to explain the algorithm. I've already done that in a lot of detail in the previous lecture. The previous lecture was around 1 hour 15 minutes long. So it was quite detailed, in which I go through the algorithm step by step and what it really means. But if you have been through the previous lecture and want to know how to code the perceptron in Python yourself, this is the best place to start. So let's get started. As is the case with all classification problems, this is how our data looks like. As I've mentioned on the left hand side of the screen, the red negative are the negative data, which means the correct answer is -1 in this case. And my positive class data has been shown by plus signs, which means the correct answer in this case is +1. So this is my data, and the aim is to construct a linear classifier. The aim is to find this straight line which is given by theta transpose x plus theta naught, which is the best classifier for the negative and the positive points. There can be so many of such classifiers, so many such straight lines we can draw. Our aim is to find the best one. So mathematically, the perceptron algorithm looks something like this. For t is equal to 1 to capital T, which is the number of iterations, for I equal to 1 to small n is the number of training data points. This algorithm says that for each training data point, you check this particular value y into theta transpose x plus theta naught. If it's less than 0, then you update the hypothesis. You update theta by adding the product of yi and xi to it. You update theta naught by adding yi to it. And then you return theta and theta naught. If you are not understanding why are we checking this particular quantity or why are we updating theta and theta naught like this, again go to the previous lecture in which everything has been explained in a lot of detail, so you can follow this lecture clearly. As is done in common practice in all of my lectures which I am doing, I don't just write the mathematical representation, but I really try to explain this algorithm in words. So let us try to understand how the perceptron algorithm works in words. So this is the mathematical representation, right? So this is mathematics. Let's see what this means in words. First, you decide the number of iterations. Let's say I want to do 10 iterations, which is this capital T. Then you initialize theta and theta naught to 0. That's your first hypothesis iteration. Let's say theta and theta naught is 0. Then you start with the first iteration. When you start with the iteration, then you go through each point in the data set. So this is given by for I equal to small 1 to I equal to 1 to small n, which means you go through each point in the data set, and for each point you check the current hypothesis prediction. If the hypothesis makes a mistake, so this if condition is given by yi multiplied by theta transpose xi plus theta naught less than or equal to 0. So if this particular value is less than 0, which means the hypothesis made a mistake for the yi and xi which we have selected, then you essentially rotate the current hypothesis so that it classifies the mistaken point correctly. So let's say the current hypothesis is like this and it has made a mistake. You rotate the hypothesis, and mathematically that rotation is also given by this update values. So mathematically rotating the current hypothesis means updating theta and theta naught. Basically, it says that if your current hypothesis makes a mistake for the point, then rotate that hypothesis until it gives a correct prediction for that point. And that rotation is given by this update. So that rotation means that theta's values need to be increased by yi into xi, and theta naught's value need to be increased by yi. Then we have to keep on going through all the data points. Right now we just looked at one data point, right? Maybe this. And we updated the hypothesis if the hypothesis made a mistake. Then you go through all the data points. You go through this, you go through this, you go through this, you go through this, and you go through this. As you go through all the data points, you keep on updating the hypothesis if mistakes are made. So basically, as you go through all the data points, you check this condition. If mistakes are made, you update the hypothesis by rotating it. If mistakes are not made, you jump to the next data point. And the final thing is you repeat this entire procedure till 10 iterations are done. So after going through all the data point once, you start with the second iteration and then repeat the above steps 4, 5, 6, and 7 until 10 iterations are done. So these are the number of iterations which you start with in the first place. And the final hypothesis which you get is your answer. Just to repeat, what you do is start with theta and theta not equal to 0. Then check, then go through each training point. Start with the first iteration, go through each point one by one, check if the current hypothesis is making a mistake. If mistakes are made, rotate the hypothesis and update it. After going through all the points once, then go through the second iteration. Again, go through all the points once and keep on updating the hypothesis till no mistakes are made. Do this process till you finish 10 iterations. The final hypothesis which remains, that is your answer. This is the perceptron algorithm in words. Now, if you did not understand this part, which means that you have not understood the previous lecture, or you have not been through the previous lecture. So I highly recommend you again to go through the previous lecture if this part is not clear to you. Now, all of these 6 or 7 or 8 steps which I've mentioned in words here, I'm going to code this in Python. Okay. So let's get started with the Python coding. As has been mentioned in the comments, I'm going to try to go through this part a bit slowly so that all of you can understand. Okay, so As always, we'll be working in Jupyter notebook files. And so I have created a file here which is called as perceptron.ipynb. Remember that Jupyter notebook files extensions are .ipynb. Okay. So if you are new to VS Code, or if you have not installed VS Code, or if you have not installed Jupyter Notebook on VS Code, if you have not installed Python libraries like NumPy, Matplotlib, etc., please go to lecture number 5 where we install VS Code, install Python, and I think lecture number 7 and 8 where we install Jupyter Notebooks. So let's get started with the code. There are two Python libraries which we are going to be using for this demonstration. First is NumPy, since we will need to initialize and load arrays. That is why the first library which we import is NumPy, and we write this statement as import NumPy as np. The second library which we will import is matplotlib, and that's why we import the second library matplotlib.pyplot as plt. These are the only two libraries which we will be needing in this perceptron algorithm code. So I write these two lines and I run this particular code block or this cell in Jupyter Notebook. Now you can see this tick mark shows, which means this code has been run successfully. The next step which I need to do is import the data points which I showed over here. This is my data. This is my ground truth data. So the data point which I have is this. For the positive, I have 3 points: -2, comma 3, 0, comma 1, and the 2, comma -1. So positive points means that the true value is +1. Uh, and the negative point means that the true value is -1, or it is the second class. So this is the first class and this is the second class. Basically, the positive class is this and the negative class is this. So 3 points in the positive class and 3 points in the negative class. Great. So I define the positive points like this. Note that I have used an array here. So array means that our points will be in a array, and then each element of the array is 1 point. So if I run this particular code block and I plot positive points, or rather display positive points, you will see that it's an array, and this array has three elements: the first point whose x coordinate is -2 and 3, the second point whose x coordinate is 0 and y coordinate is 1, and the third point whose x coordinate is 2 and y coordinate is -1. Similarly, if you run the negative points, you will see that it is also an array, and that particular array has three elements. The first element is the first point whose x coordinate is -2, y coordinate is 1. The second point whose x coordinate is 0, y coordinate is -1, and the third point whose x coordinate is 2 and y coordinate is -3. So the reason we downloaded the NumPy package is because we can define arrays very easily using np.array. So np means that we are using the NumPy package to define or create the array in the first place. Great. So we have defined the positive points and the negative points, which means we have defined our data. The next thing is to plot the data points. What we will do is that we will show the positive points in a blue color with the O marker or the circle marker. We will show the negative points in a red color with the X marker. We will label the positive points as positive class. We will label the negative points as negative class. The x-axis label we will give as x1 and the y-axis label we will give as x2. So let me run this. So here you can see the plot has appeared, and it looks very similar to what we had over here. X-axis label is x1, y-axis label is x2. As we can see here, x-axis label is x1, y-axis label is x2. The negative class points are given here, which are very similar to the 3 points which we had, and the positive class are given by these blue dots, which are also very similar looking to the three positive points which we had in our diagram. and then the positive class are labeled as, or the legend is positive class, and the negative class is labeled as negative class. So this is why we downloaded the or imported the matplotlib library, because we needed to plot things. We needed to plot these points. We needed to plot an xy grid with x labels and y labels. And you can look at the plotting command. It's very simple. We showed the positive class points as negative class points as single points, right? So that is also called as scatter plot. So we use the command plt.scatter. The first thing we showed is a plt.figure, which means first we are showing a figure with size 8 and 6. You can play around with the size here. Then we show the scatter points on top of this, which means we show these points, the positive class and the negative class. And then we say that I want the x label to be denoted as x1, I want the y label to be denoted as x2, I want the title to be denoted as initial data points, and I want to show the grid, which means the xy grid. And then I want to show this plot. That's why we say plt.show. And the reason we are using plt is because we imported matplotlib.pyplot as plt. Great. So the second step has been done, which means that we have loaded the points and we show them as a plot. Now what we will do is we will combine all the training data together into an X array, and we will combine all the testing or the Y axis into a Y array. So essentially, the way to combine all the positive and negative points, we are using a command called np.vstack. So what this command does is actually, let's say there is an array 1 which has the value 1 comma 1, 2 comma 2, and 3 comma 3. Let's say this is the first array, and let's say this is the second array, which is 4 comma 4, 5 comma 5, and 6 comma 6. What np.vcat does is that it vertically concatenates all this array, which means that it vertically stacks them on top of each other. So what np.vstack does is that np.vstack of array 1 and array 2, what it does is that it creates an array 3, which is a vertical array, and it contains 6 elements. It contains 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4, 5 comma 5, and 6 comma 6. So this is the meaning of vertical stacking, or np.v stack. So this is exactly what we are doing here. X equal to np.v stack positive points and negative points. So we are vertically stacking the positive and the negative points. So if you run what x means, you will see that it shows this value. So these three are the positive points and these three are the negative points. They have been stacked on top of each other. Then what this y is equal to np dot array 1 into length of positive points plus 1 into length of negative points. What this does is that we have we have positive points. So this is the x value. Let's say we have three x values, or the coordinates. So x1 comma x2, y1 comma y2, or x1 comma y1, x2 comma y2, and x3 comma y3. These are the points, and the true value of these points is plus 1, right? The true value of this points is plus 1, and the negative points are also three negative points, and the true value of these negative points is equal to minus 1. So by that np.vstack command, we collected all these points into a single vertical array. So that is x. But now what we want to do is we want to collect all of these points also in a vertical array. So what we want to do is that we want small y to be equal to plus 1 plus 1 plus 1 minus 1 minus 1 minus 1. So this is what actually we are doing by this second statement. which is np dot array 1 into length of positive points, which means the first three values of the new array will be equal to 1, these first three values, and then plus minus 1 into length of negative points, which means that the second three values will be equal to minus 1, minus 1, minus 1, minus 1. This is what we are doing. We are essentially creating the small y array with this statement. So if you run what small y actually means, you will see that it consists of six values, plus 1, plus 1, plus 1, minus 1, minus 1, minus 1, like what we have done here, like what I showed over here. So essentially, with this particular command, we combined all the positive points into one big array called x. Sorry, we combined all positive and negative points into one big array called x, and we combined all the labels associated with those points into an array called small y. So you can think of this as input array and the output array. And now we define the perceptron algorithm. So perceptron algorithm is a function which consists of the input data, which is the array of inputs which we have collected, the capital X which we found here, this input. Then it also takes as an argument the y values, which are the actual values. So plus 1, plus 1, plus 1, minus 1, minus 1, minus 1, and the number of steps or the number of iterations which we are going to do. So if you look at this algorithm, first we have to decide the number of iterations which we need to do, right, this particular part. So let's say 10. So that is another input which we need to give to the perceptron algorithm. So initially we have started with 10 steps or 10 iterations. Then as I mentioned, the next step is initialize theta and theta naught to be equal to 0. This is the next step, and this is exactly what we are doing over here. So theta is initialized as a zero array. Np dot zeros means that we are creating an array where all values are equal to 0. Remember, theta is a vector whose length is equal to the number of features which we have. So here there are two features, right, x1 and x2. So theta will be equal to an array with two zeros. So essentially theta will start out as 0 comma 0, and theta naught will start out as 0. This is just a scalar value. Okay, and then we define these two loops. The first loop is do the number of iterations which is equal to 10, and the second loop is go through every single data point. So this is what has been mentioned here. Go through each point in the data set, which is given by this particular line of command. Enumerate capital X, which means that for the length of whatever is there in X, you go through every single point. And remember, now capital X has all of our data points stacked on top of each other. First the three positive points, then the three negative points. So we are going through all the data points in that data set, and then for each point we have to check this condition, right? So if yi into theta transpose x plus theta naught is less than 0, so this is exactly this part, we are checking this condition, which means we are checking if the hypothesis is making a mistake on the current point or not. So yi multiplied by theta transpose xi plus theta naught, this is exactly what has been written over here. Yi multiplied by, so np dot dot means theta transpose xi. That's a dot product between the theta vector and the xi vector, which is the current point. And then we add theta naught. And if this product is less than 0, which means if an error has been made, we update theta and theta naught. And how are theta and theta naught updated? Theta is updated by adding yi into xi to it, and theta naught is updated by adding yi to it. Yeah. So if you look at the code is actually exactly similar to what has been written in terms of the algorithm here. The only change is probably the np dot dot, which is we saying that theta transpose xi just means taking a dot product between theta and x. But everything which has been written down on paper is exactly the way you have to write this Python code. So it is actually very easy to write this particular algorithm in Python. It's just 1, 2, 3, 4, 5, 6, 7, 8, 9 lines of code. That's it. There is another line here which is basically plotting. So this I have added from my side because I want to show you after each iteration how that hypothesis looks like and how it eventually converges to the correct answer. But if you don't want to see this plot, you don't need to see, you don't even need this particular line. Uh, it's just 9 lines of code, that's it. And I think this will be really very easy to understand once you understand this algorithm. And in words, what we are doing in the perceptron algorithm, we are first initializing theta and theta naught to 0. We are defining the number of iterations. Then we are going through every single point in the data set. We are checking if a mistake has been made or not. If a mistake has been made, we update theta and theta naught. Then we again go through the next point in the data set till we reach the end of the data set. Then we go to the next iteration. We keep on doing this for, let's say we have 10 iterations. We keep on doing this, going through each data point for 10 times. And the final theta and theta naught which this process returns is our final answer. Now I have added one more command here which is plot decision boundary at the end of each iteration. So after we go through every data point once, I am going to plot the decision boundary to show you how the line evolves or how our hypothesis prediction evolves. So this plot decision boundary is basically just a function where we plot the straight line at the end of the hypothesis. So I'm not going to go through the details of this because it's just plotting that straight line. But you can have a look at this plotting function. It's basically very similar to the plotting commands which we used here, such as scatter, x label, y label, etc. So just go through the code file when I'm going to upload it. But this is just a decision boundary which we plot after every iteration. So now actually let's run the perceptron code. So here we just define the function. Now here we just define the function. Now it's the time to run the perceptron function. So theta final and theta not final are the results which I want. And then I run the perceptron function. I give the inputs as x, which is my x data set, the vertically stacked data set. My y is the plus 1, plus 1, plus 1, minus 1, minus 1, minus 1, those values. And the 10 is the number of iterations which I want to do. So I'll be showing you 10 different plots after each iteration, how the straight line is. So let me run this. And now see, you can see it's taking time, 3 seconds, 4 seconds. So in 4 seconds this entire code has been executed for 10 different times. So let us see the decision boundary after every iteration. So you can see that this is the first decision boundary and it is very bad. It has essentially made how many errors? It has made an error here and it has made an error on this point. So it, since the normal to this decision boundary is over here, it will classify this red point as positive and it will classify this blue point over here as negative. So it will make two mistakes. Remember, when a mistake has been made, our algorithm rotates the hypothesis. So in the next iteration, you will see that the hypothesis is rotated so that we avoid the mistakes. So it is rotated in the clockwise direction. Still we can see that it passes through 2 points and still it's not quite perfect. This is the iteration number 3 where it actually makes two mistakes again because the normal to this is here. So it does classify the positive points correctly, but it incorrectly classifies these three negative points. So still there is an error. So we need to then again rotate it backwards. We need to rotate it anti-clockwise because the final line which we want is this. So remember, when going from iteration 1 to iteration 2, we rotated the hypothesis clockwise, but then we turned 2 clockwise here. This is going in the wrong direction. So then we again need to rotate it counterclockwise. Then you can see that in iteration 4, we have rotated it counterclockwise a bit, but there is an issue because it classifies many points incorrectly. So the positive normal is here. So it classifies this point as positive, which is wrong, and it classifies these two positive points as negative. So it's again wrong. So we need to further move it in an anti-clockwise direction. Iteration 5, we do move it anti-clockwise, but still there are issues. It classifies the positive points correctly, and it makes mistakes on two negative points. Then in iteration 6, we kind of have to turn it clockwise again because we want it to pass in the middle between the positive and negative. So we turn it clockwise and now it's doing a bit better. Still there are issues because makes an error on this point, it makes an error on this point, it also makes an error on this point. So then we have to turn it clockwise, sorry, turn it anti-clockwise again. So we try to turn it anti-clockwise, and we see that it is making correct predictions on the positive points. It is making correct predictions on two negative points, but it has made an error on one negative point. So it is getting close. We need to again turn it clockwise, I think, yeah, so that it passes through the middle. And now you see we turn it clockwise, and now it leads to the perfect answer. At iteration number 8, the straight line which we see perfectly separates the positive class from the negative class. So we have converged to the correct answer in 8 iterations. And then iteration number 9 and iteration number 10 is the same, because no mistakes will be made. So if no mistakes are made, then our perceptron algorithm does not update anything. Look at this particular step. It only updates theta and theta naught when a mistake has been made. If no mistake has been made, it does not update theta and theta naught. So after iteration number 8, the value of the best hypothesis which we have essentially stays the same. So in 8 iterations of the perceptron algorithm, we have reached the correct answer. And this is coding perceptron algorithm in Python. You can actually see how easy it was. It just requires following 3 steps. First step is loading the correct packages, NumPy for array manipulations and matplotlib for plotting. The second step is loading the data points and stacking them correctly. So first we load the data points and visualize them. Then we need to stack all the training points, all the input values in one long array, and we need to stack all the output values, which is plus 1 plus 1 plus 1 minus 1 minus 1 minus 1. Then this input and output will be fed to the perceptron algorithm. The third step is to define the perceptron algorithm. And if you have written down this algorithm mathematically, or if you have understood it in words, it's actually very similar to your understanding. First initialize theta and theta naught to 0, decide the number of iterations you want to do, which is given by steps. Here we are doing 10 iterations. In each iteration, go through every single point of the data set and check whether a mistake has been made. If a mistake has been made by the hypothesis, rotate the hypothesis, which means update theta and theta naught. Keep on doing this for all the data points. Once you have reached or covered every single data point, plot the decision boundary at the end of that iteration. Then go to the second iteration. Again go through all data points. Similarly, keep on doing this 10 times. The final answer which you get is your optimal theta and theta naught. So here again we saw that initially the hypothesis which was returned after iteration 1, 2, 3, 4, 5, 6, it is making errors. But slowly the algorithm is learning on its own. Here you see, this is why it's called machine learning, because the computer program is learning on its own what the correct classifier is. So currently it makes a mistake. So here it's like this, right? It's making a mistake. Then it turns itself like this. Then it turns itself like this. Again like this. Iteration 6 again like this. Iteration 7 is like this, but it's still not correct. Iteration 8 it's like this, where it's finally correct. So this kind of turning is machine learning visually. So the algorithm or the straight line learns from its mistake and it corrects itself, right? This is the true essence of ML or machine learning. And you saw how easy it was to implement the perceptron algorithm in Python. Very sadly, modern ML courses such as the Microsoft course does not cover the perceptron algorithm, and it directly jumps to regression, classification, etc. But in fact, in classification itself, one of the foundational algorithms is the perceptron. And before coming to practical demonstrations of the classification uh, algorithm, it's very important to understand the fundamentals very, very clearly. So, up till now, we have looked at the following classifiers. We have looked at the random linear classifier with the cats and dogs example, I think in lecture number 6 or lecture number 7. Here we defined the random linear classifier. And the second algorithm which we have looked at right now and tested in Python is the perceptron algorithm. So we have run two different algorithms on Python now, the random linear classifier algorithm and the perceptron algorithm. Classification also involves many other algorithms, such as k-means classification, the clustering algorithm, several other algorithms which we will come to. So, for example, in the Microsoft course of classification, it does not go through random linear classifier. It does not go through the perceptron algorithm in detail, but it goes through linear classifiers and something called as logistic regression. So it goes through linear classifiers and logistic classifiers, but it does not use the random linear classifier algorithm which we learnt about. So it directly jumps into complicated things a bit, and that's why I did not go into these things earlier. So if you look at the kind of classification algorithms which they use, they directly start with support vector machines, linear models, and all these things, but they don't look at fundamental options such as perceptron, the random linear classifier, etc., which really teach us a lot about the correct algorithm to use. In the next lecture, we will be looking at something which is called as margin, something which is called as linear separability, etc., which are theoretical concepts which are introduced in the MIT's course very nicely. After which we'll be moving towards features, margin maximization, and then we'll move to regression. At that time, we'll also look at logistic regression. So I hope everyone is following with me up till now. Up till now, what you have learned is introduction to ML, types of ML. Then you learnt about linear classifiers and you learnt about two linear classification algorithms, the random linear classifier and the perceptron. Both of which you learned the theory, the fundamentals, and you also learned the coding, which is the main purpose of the series which I'm making. I don't just want to show you the codes. I want to show you a lot of detail about the fundamentals. That's why the previous lecture on the perceptron, these are the notes for that lecture. That was 1 hour, 10 minutes long. And it was meant so that you understand this coding lecture in a lot more detail. Okay, I think this brings us to the end of this particular lecture, everyone. Thanks a lot for following with me. And as I've already mentioned before, please try to execute the code files which I'm uploading. Please try to write down the perceptron algorithm on your own so that you can see how it is working, how it learns. In fact, in last lecture, we looked at the iterations of the perceptron manually. We took an example and we saw how the line rotates manually without even coding. That just gives us a lot of intuition about how a machine learns. So this is the kind of hard work which you will need to do. The reason I'm making this series and learning in front of you is that you also remain motivated along with me. So thank you everyone. We'll see you in the next lecture where we'll look at margin. We'll look at the theory of separability. After which we are going to move towards very interesting things such as feature representation, margin maximization, and logistic regression. Thank you so much, everyone. I'll see you in the next lecture.